What if light could stop moving? Light always travels at 299,792 kilometers per second. Or does it in 99 scientists actually stop light inside a cloud of atoms? What if I told you that everything you thought you knew about light, this fundamental force that paints the world around us, might be fundamentally wrong? It seems almost impossible to imagine a universe where light traveling at an astonishing 299,792 kilometers per second simply stopped. But in 1999, a team of brilliant scientists at the University of Colorado actually managed to do just that, creating a bizarre and utterly fascinating phenomenon within a cloud of atoms. Think about it like this. We often describe light as waves, like ripples spreading across a calm lake, or particles, tiny packets of energy zipping through space. And while both descriptions are helpful, they only give us a partial understanding of its incredible behavior. For centuries, the prevailing view was that light always travels at this incredible speed, an absolute constant, a bedrock of the universe, and that it simply passed through space without any resistance. However, the experiment at the University of Colorado demonstrated something far more complex, something that challenged our most basic assumptions about the nature of light itself, and perhaps even about the nature of space and time. The researchers, led by Dr. Stephen Lamb, used a highly specialized laser Wi-Fi device that generates a concentrated beam of light free to bombard a cloud of cold cesium atoms, which are essentially tiny, perfectly ordered spheres of matter. Cesium atoms were chosen specifically because their electrons, the tiny particles orbiting the nucleus, have very well defined energy levels, meaning they can only exist in specific quantized states like steps on a staircase, rather than a continuous ramp. Now, when the laser light hit these atoms, it caused the electrons to absorb energy and jump to a higher energy level, a process that normally happens instantaneously with no delay or measurable time difference. But what the scientists discovered through incredibly precise measurements using atomic clocks and sophisticated detectors was that the absorption of light by these atoms actually slowed down the side propagation of the light itself, essentially creating a bubble of slowed light. Imagine a swimmer trying to move through water, and suddenly the water begins to thicken to resist their movement, making it significantly harder for them to glide through. That's a rough analogy for what happened to the light, which is normally thought of as traveling through space without any interaction. The laser light didn't simply pass through the cloud of atoms. Instead, it interacted with the electrons, creating a temporary distortion in the space around the atoms, effectively slowing the speed at which the light was traveling. This distortion wasn't a complete stop, of course, as light still managed to transmit information, but it was demonstrably slower than the speed of light in a vacuum, a truly astonishing result that defied conventional wisdom. Scientists had previously theorized about the possibility of light interacting with matter in this way, but this was the first time it had been observed with such precision and clarity, providing compelling evidence for a deeper connection between light and space itself. The key to understanding this phenomenon lies in the concept of the quantum vacuum, a theoretical construct that describes empty space not as truly empty, but as teeming with virtual particles that constantly pop into and out of existence, driven by the uncertainty principle. These virtual particles aren't real permanent objects, but they represent the lowest possible energy state of space, and they play a crucial role in mediating interactions between light and matter. When the laser light interacted with the cesium atoms, it disrupted the delicate balance of these virtual particles, creating a temporary ripple in the quantum vacuum. And this ripple effectively slowed the light's propagation. It is like trying to push a marble across a trampoline. The more you push, the more the trampoline bends, and the harder it becomes to move the marble because of the distortion. This experiment didn't just demonstrate a new way to slow light, it opened up entirely new avenues of research into the fundamental nature of space-time itself, suggesting that space isn't an empty void, but rather a dynamic and interactive medium. The implications of this discovery are profound, potentially leading to breakthroughs in areas like quantum computing, telecommunications, and even our understanding of the early universe. Just after the Big Bang, when the universe was incredibly dense and hot, scientists are now exploring ways to manipulate this interaction between light and the quantum vacuum, potentially harnessing it to create new technologies that could revolutionize how we communicate and transmit information. Think about the possibilities if we could control the speed of light, even for a brief moment. allowing us to send information instantaneously across vast distances, bypassing the limitations imposed by the speed of light. The University of Colorado experiment represents a monumental shift in our understanding of light and space, reminding us that the universe is full of surprises and that our most cherished assumptions can be overturned with careful observation and innovative experimentation. It is a powerful illustration of how science constantly evolves as we probe deeper into the mysteries of the cosmos, continuously pushing the boundaries of what we thought we knew. So, the next time you see light, remember that it's not just a wave or a particle, but a fundamental force that interacts with the very fabric of space and time. A force that scientists are now actively trying to understand and control. The exploration of this phenomenon continues today, with researchers striving to replicate and expand upon the original experiment, seeking to unlock the full potential of this astonishing discovery. It truly highlights the remarkable journey of scientific discovery, where a seemingly simple experiment can lead to a radical transformation in our perception of reality. And it begs the question, what other secrets does the universe still hold, waiting to be revealed by the relentless pursuit of knowledge?